talking about Lev's classification, to which we have added intact ventricular septum. And Andrew has just shown you how it is the attachment of the outlet septum that puts the defect between the limbs of septomarginal trabeculation either into the subaortic position or into subpulmonary position. And we can now continue that approach to the ventricular septal defect, because what I'm going to show you is that the essence of the doubly committed defect is that that muscular septum is lacking, the muscular outlet septum, and so that then permits the defect in the same place to look into either the aorta or the pulmonary trunk, and hence to be doubly committed, whilst when the defect is not between the limbs of septomarginal trabeculation, that is when it becomes non-committed. So everything depends upon the limbs of the septomarginal trabeculation and their relationship to the muscular outlet septum. So here is the essence of the doubly committed defect. You're looking up from the apex of the right ventricle, and hopefully by now you can recognize the tricuspid valve. And you can see here we have the limbs of septomarginal trabeculation. And once again, the interventricular communication is cradled within the limbs of the septomarginal trabeculation. And there is the defect. But now, in the roof or the superior margin of the defect, we no longer have a muscular outlet septum. Instead, we have a fibrous raphe that is beneath the conjoined leaflets of the aortic and the pulmonary valve. And because there is no muscular outlet septum tethering the outflow tracts to either the anterior limb of the septomarginal trabeculation or the ventricular infundibular fold, now the interventricular communication is able to look either into the posterior aorta or into the anterior pulmonary trunk, and hence is interventricular. And note that if I take the star away, there is a minimal muscle fold here where the posterior limb of septomarginal trabeculation fuses with ventricular infundibular fold. So in this instance, the defect does have a muscular posterior inferior rim, but in other instances, that fold may be effaced so that there is mitral to tricuspid valvar continuity incorporating the aortic valve, in which instance the defect will be perimembranous. So the doubly committed defect exists because there is nothing to anchor the subarterial outlets. And because of that, there is also a spectrum of malformation with this lesion towards double outlet left ventricle. And in an important paper written in the early 1980s, the group from Green Lane in New Zealand, Peter Brandt, sadly no longer with us, Sir Brian Barrett-Boy is also sadly now passed away, said that we should call this double outlet both ventricles. And there is much to commend that approach, because certainly both arterial valves are looking into both of the ventricles. So, if you wish, double outlet both ventricles. And usually this is seen with deficient infundibular structures, not only the muscular outlet septum, but also with fibrous continuity between the aortic valve and the mitral valve. So the final consideration to complete our spectrum of lesions that have double outlet connection from the morphologically right ventricle are those with the non-committed defect. And the essence of the non-committed defect is that it is remote from the outlets. So in essence, we are talking about those cases that either have inlet or apical muscular defects, or alternatively perimembranous defects extending so as to open primarily to the inlet of the right ventricle. And these are the cases that are often seen with common atrioventricular junction, so coexisting atrioventricular septal defect. And there can be a problem in determining when these defects become committed to the aorta or the pulmonary trunk and when they are non-committed. And that, as with all these situations, is a matter of personal choice. But in this instance, there is no question but that the defect is non-committed. Here is the outlet septum, shown by the star, exclusively a right ventricular structure. And you see that the tricuspid valve is now interposing between this muscular inlet defect and both of the outflow tracts. So there is no question that the defect is non-committed, as is this one that is shown by the probe passing through from the right ventricular inlet to the inlet of the left ventricle. In this instance, the defect is perimembranous. It has extensive inlet extension. Once more, the outlet septum interposing between the outflow tracts, and you note that the tension apparatus of the tricuspid valve is attached to this outlet septum, blocking the way between the perimembranous inlet defect and here the aortic valve. You could argue that this defect is potentially committed to the pulmonary area, but look at all these muscularized tendinous cords that again interposing between this defect and preventing adequate surgical transfer of that hole to act as the outlet to the pulmonary area. So the non-committed defect, there is a spectrum from commitment to non-commitment, and not everybody will agree that all the defects described as non-committed are in fact non-committed, the more so when the surgeon has connected them up to one or other outflow tract. So in many ways, non-commitment is in the eye of the beholder. And in part, this relates to the length of the subarterial infundibulums, in addition to the location of the septal defect in itself. So what seems to be anatomically committed can be considered by some surgeons to be non-committed, but vice versa. What some surgeons describe as non-committed, other surgeons would consider to be committed. So there is still no agreement as to the precise rules for commitment. What certainly is important is the associated malformations. So what we've tried to show you over our last three presentations is the double outlet right ventricle is not an entity in itself. It is a heterogeneous group of phenotypes that are unified because there is the same ventricular arterial connection, namely the greater part of both arterial trunks supported by the morphologically right ventricle. And it is the attachment of the outlet septum that is the key to the distinction between these subsets, giving us the variants that can be described as fallow-like or ventriculoseptal defect-like, depending on the presence or absence of pulmonary stenosis, the transposition variant, the so-called Tausig-Bing malformation, the doubly committed variant, which merges into double outlet left ventricle, and finally the non-committed variant.